Okay, Assalamualaikum and good afternoon. Today we are continue with our next module, module 5, STP concept. STP by name itself a spanning tree protocol. So we are expecting to see something like a tree. By the name itself, you should know what is a tree. In this module, there are several topics that we are going to touch or to go through. First, we will go through the purpose of spanning tree protocol, and then the spanning tree protocol operation. And lastly, evolution of spanning tree protocol. Okay, let's go to our first topic, 5.1, purpose of spanning tree protocol. Why do we need to have a spanning tree protocol? So before we take a look what is a spanning tree protocol, we see what is the current problem that we gonna face. Okay, one of the feature that we would like to have in our network is a redundancy. We would like to deploy a redundancy to create an alternate path. Okay, in our switch network, you might have a single path in order to travel from one switch to another switch. But we sometimes need to have a backup path. So we need to have an alternate path. But by creating an alternate path, we have a potential to create a loop. Because if we can go to one switch to another switch through one path, and then we can go to other path, which means the data can travel and come back inside a loop. So a loop is not a good thing in a switch network. So we try to prevent a loop. That's why we need to have a spanning tree protocol. So spanning tree protocol will prevent a loop. So just take a look in this diagram. So we have like switch 1, switch 2, and switch 3. So we have a multiple connection from switch 2. In order to go to switch 1, we can go straight through tran 1 to switch 1, or we can go through tran 2 and tran 3. Also can reach switch 1. So we have a alternate path here. We have a backup. But this situation will create a loop. A data, let's say a broadcast from switch 2 can go to switch 1 and go to switch 3. And from switch 1 forward back to switch 2 and go to switch 1 and keep looping. So a looping can take over a network. It's not just same data travel around, but sometimes in a switch the data will be duplicated. So let's say there is a looping from S1 here, a broadcast from S1. So data will be sent to on S2. S2 need to send a broadcast. So will be sent to S1 and S3. So it has been duplicated into 2. So S1 will be forward to PC4 and S3. S3 when they receive, they forward to S1. But S3 also receive from S1 and forward to S2. S1 also receive from S3 and forward back to S2. And then S2 will forward back out to all other ports, and then the data will be keep multiply, and at the end it will consume all the bandwidth and the network will be down. That's the problem with the layer 2 loop. So spanning tree, by the name itself, you should can imagine or know how the tree works. Okay, a tree we can start with a root. Starting from the there is no root in here, but we can just imagine there is a root, and then we go along with the trunk, and then there's the branches, and then the leaf. But there is no looping. They cannot connect back. Of course, in the real tree, you can see a leaf may overlap with other tree, but they have no connection actually. They have no looping. So they must end at one point. So that's a tree. So in this diagram, in the network diagram, we don't want a situation with a loop like this. So we would like to have one root, and then it became branch out until they are at the end. So let's say from switch 1, it will be branch out to switch 3, and then branch out to switch 2. So switch 2 and switch 3 cannot have a connection together. So that's the purpose of spanning tree. So when a spanning tree block a connection, so we create STP, spanning tree protocol, block a connection. So create a tree, a network like a tree, but they still maintain the connection physically. What happened actually, they just block logically. So real data cannot travel to that, but there is some other data who still can travel to that path. But if we have a problem with the current path that we select earlier, let's say the path has been down, so we will reopen back the other path that have been blocked together before that. That's what happened after the failure. So the spanning tree will do a spanning tree recalculation and reopen back the link. So we'll still have a new tree, but with a new path. So there is an issue with the redundant switch link. So what we have here is a redundant switch link. So multiple paths exist between two devices. So between, let's say, from switch 1 and switch 2, it can go through trunk 1 or it can go through trunk 3 and trunk 2. So we have a multiple path between switch 1 and switch 2. But in this implementation, there is a possibility to have a layer 2 loop. So a layer 2 loop may result in MAC address stable instability. So how MAC address stable instability can happen? Let's say PC1 are sending a broadcast. So they have a MAC address, let's say AAAA. So switch 2 we record a packet frame coming from F011 have a MAC address as a AAAA inside their MAC address table, and then they broadcast are sent to all other port. Trunk 1 here to switch 1, to switch 3, to PC2, to PC3. Okay. So now the broadcast has been received by switch 1. Switch 1 also record the MAC address of AAA are located at the port F0/1. And switch 1 will be forward the broadcast to all other port F03 and F02. Okay, now switch 3 will receive a broadcast from PC1 from F0/1. So switch 3 will record MAC address of PC1 inside the MAC address table with the label of F0/1. But at the same time, switch 2 also send the broadcast, the same broadcast to switch 3 on the port F0/2. So now switch 3 have received the same frame, or from a point of view switch 3, it doesn't know it's the same frame, but a frame for the same MAC address from multiple source. It received from F0/1 and update in the MAC address table, and then later it received from F0/2 and update. So it will be keep updating. So if in this situation we only have 2 port, but in the multiple switch you might have multiple other port. So it will be keep updating on all other port, and the switch will not be able to determine where is the real path that can go to AAAA. So we have instability of the MAC address table inside every switch. Later on, switch 2 also already record on F0/11. But switch 3, when they receive a broadcast from switch 1, switch 3 will forward back to switch 2. So now switch 2 will record, oh, I'm received a new frame from AAAA through a port F0/2. So it will be update from here. The frame that has been sent to switch 3 will be forward to switch 1, and switch 1 will forward back to switch 2. And then switch 2 also will update their MAC address table with the port F01 with the MAC address AAAA. So later, we do not have a stable MAC address table inside every switch. Okay, link saturation. As I said earlier, when a switch receives a broadcast, it will send to all other ports. So which means the frame will be duplicated, and then the data will be flow through the network, and at some time will be saturate our network. So the other data cannot go through. And for the switch itself, they need such a many processing, so they might use a high CPU utilization. And at the end, resulting a network become unstable, which is all other data cannot go through our network. So that's for a switch. But when we're talking about a protocol for the internet itself, whenever they send a data, a frame, they have a TTL, time to live. So whenever a data travel from one hoop to another hoop, one device to another device, they will reduce the TTL, time to live. So when the TTL has gone to 0, and then they will drop the packet. So the data can be looping all around until their TTL be 0. But before they reach 0, they may already saturate the network. This is what will happen if we do not have a spanning tree protocol. So the frame will be looped endlessly and can down the network quickly. So there is another problem, broadcast storm. Broadcast storm, okay, whatever I explained to you before, when a PC send a broadcast, it will be duplicate and then will be keep rounding inside the network. So that thing we call as a broadcast storm. And then the broadcast storm also we constantly change the MAC address table, because at one time a switch receive the same frame with the same MAC address from the other port, and then after that receive from other port and other port. So it will make our switch unstable. So here came a spanning tree algorithm in order to build a spanning tree protocol. So spanning tree protocol are using spanning tree algorithm, which is invented by Radia Perlman. I think I already shared to you a poem by Perlman by the name algorithm. So the poem actually based on her paper and algorithm in distributed computation of spanning tree in extended LAN. So from there, we have a spanning tree protocol. So what a spanning tree protocol do actually? Prevent a loop from occurring by configuring a loop-free path. So how to create a loop-free path? By do some blocking. Create a block, a logical blocking. Place a blocking state port, and then the switch running spanning tree are able to compensate a failure. If the port that we have choose not to block to open, but sometimes there is a problem, we cannot send the data through that port or through that link, so spanning tree will open back that blocking state that we put on other link before. So it will be used as a backup. So how does they create a spanning tree? I mean, yes, a spanning tree with a loop-free topology. So first, they need to elect a root bridge. Just imagine a tree, we must have a root. So from all of the switch within the network, one switch must be declared as a root bridge. So how to select a root bridge? All the switch must elect between all of them. They need to keep exchanging the information. So after certain time we have a conversion, so they come to conclusion one switch must be a root. So the all other switch must follow or use that root as a reference point in order to build a tree. So when we have a root and we have a path, all other trees should have a path toward the root. So when we have a path toward the root, so we need to block a connection to other switch that create as a alternate path to the root. And then we have a loop-free topology. And the algorithm also we do a recalculation. As I say, if the link going down, so we open back. But we take a look one by one how to select a root bridge, how to block redundant path, and so on. Okay, there is a video in our NetAcad, so I want you to go there and see the activity. Just play the video, see how the spanning tree work, how they build the spanning tree. And we also have a packet tracer activity we will done within lab session, packet tracer 5.1.9. So in this we will create a simple network. Okay, for your information, by default, all Cisco switch has been enabled with the spanning tree protocol. So most of the time, you have to do nothing in order to make use of the spanning tree. By default, they already use the spanning tree. So in this activity, what we would like to do actually investigate, to view, to observe how they build the spanning tree. And after that, we will try to disable spanning tree and view operation again.